I'm Sarah, and I just want to start with a thank you to family and friends and mentors who are here today showing their support. It means a lot. Okay, so let's dive into advancing the adoption of algae for cattle feed to reduce methane emissions. So methane, seaweed, and policy might not seem to have anything to do with one another, but today I'm going to talk about how seaweed can be used to stop cows from producing methane and how I explored the ways in which policy could play a role in widespread adoption of this technique. So before we get into the cows and the seaweed, let's take a step back. So on a global scale, greenhouse gas emissions are rising, and they're rising at really alarming rates. Increased greenhouse gas emissions are driving so many of the environmental changes and the catastrophes that we're seeing today. Things like more frequent and intense storms, coastal flooding, and our oceans getting warmer, rising, and becoming more acidic. And when we hear the term greenhouse gas, a lot of us think about carbon dioxide. It's sort of the poster child of greenhouse gases. But we're going to take a look at a different greenhouse gas, methane. So methane has more than 80 times the warming power of carbon dioxide over its first 20 years in the atmosphere. So even though CO2, carbon dioxide, has a longer lasting effect, methane sort of sets the pace for warming in the near term. And now let's get even more specific, and let's talk about a sneaky source of methane, which is methane from livestock. There are two main ways that livestock contribute to methane: through their belches and when their manure is stored in large quantities. So cows are ruminants. Ruminants are a type of animal that has multiple stomachs, and they actually ferment their food in these stomachs. So this is a process that's called enteric fermentation, and methane is created as a byproduct of the fermentation and is belched out by the cow or the animal. And this is just a natural part of the cow's digestive system, and it happens all day long. On the other end, when manure is stored in large pools, and this happens on all large scale farms, the conditions actually become anaerobic and the manure starts off-gassing methane. And it might not seem like just some cow burps and some poop is really that big of a problem, but it turns out that methane from agriculture makes up 36% of all the methane emissions in the United States. So it's not insignificant. And if we look specifically at agriculture, we learned that of that 36% of emissions, most of that's actually coming from enteric fermentation, or the burps. So what's being done about this? In short, not a lot. We can think about this, there are two ways that we can address this: from the front end with the burps or the back end with the manure. And for a while, people have actually been attempting to address the methane that's off gas from these manure ponds with these machines called anaerobic digesters. And maybe you've heard of these before. So they're basically devices that take the methane from the manure and convert it into usable energy. The problem is these are really expensive and they require equipment, installation, and maintenance. So the US government has programs that are supposed to subsidize the costs and help farms install them, but the efforts have been really slow and have run into a lot of issues. In addition, these manure digesters aren't really clean or green energy. So burning biogas for energy converts methane into carbon dioxide, and it also produces carbon monoxide, nitrogen oxides, sulfur dioxide, and other hazardous air pollutants. So the carbon dioxide generated during anaerobic digestion and during the combustion of methane is released into the atmosphere. So it's not eliminating methane, rather it's just repurposing it. So let's instead look at the methane belched out by cows. Is there a way that we can actually stop the methane from being produced at all in the first place, instead of just trying to repurpose it? And this is where the seaweed comes in. So specifically, we're talking about one species of red algae. It's called Asparagopsis taxiformis, which I know is a mouthful. I'm going to be just calling it Asparagopsis for the rest of this talk. So Asparagopsis is a red seaweed. It grows in tropical to warm temperate waters, and it contains a really high concentration of bioactive compounds. These compounds in the seaweed interact with the production of methane inside the cow's gut. And it turns out that feeding cows just a pinch of this seaweed actually reduces their enteric methane dramatically and consistently by 80%. So we know this algae exists and has a really cool potential, but how do we get it out of the oceans and onto farms? And this is where Blue Ocean Barns comes in. So there are a small handful of companies that are trying to make this work. Blue Ocean Barns is one of them. They're a US-based startup, and they are the company that I worked with for my capstone. So let's take a look at what they were doing before I joined. Blue Ocean Barns has been working with scientists at Scripps and UC Davis to perfect their method of cultivating Asparagopsis, which is no easy task, and drying it and processing it for cows to be able to eat palatably. They have facilities in Hawaii where they grow the seaweed in large tanks on land until it's ready to be processed and dried. But what is missing from this? And that's where my capstone project actually comes in. So this is a totally novel technology. It's never been done before in the livestock sector. So there isn't really a pre-existing framework. And this is the piece of the puzzle that I worked on for my project. I worked with Blue Ocean Barns on how to navigate regulations and use policy to ensure the adoption of Asparagopsis at meaningful levels across the country. So I'm going to take you through sort of the process I went through on the path to regulation and adoption. So this includes answering the questions of why Asparagopsis and why Blue Ocean Barns with something called a competitive analysis. I also did a life cycle analysis, which determines the true emissions reductions possible with Asparagopsis. I did a deep dive into regulation and developed policy briefs. So we're going to start with these two key questions, which I answered in a competitive analysis. So seaweed is actually not the only additive with a claimed potential to reduce methane. There are a handful of other supplements and technologies that all aim to eliminate methane from enteric fermentation. These include garlic, citrus, lipids, a compound called 3-NOP, and even a mask that's supposed to capture burps from the cow directly. And so I analyzed the positioning of Asparagopsis compared to these other methane reducing techs, looking at the quantity needed for reduction, the methane actually reduced, and its sustained impact. And after a lot of research, I found that overwhelmingly Asparagopsis outperforms the other additives in each category. And this is just a graphic that shows basically seaweed's ability to reduce methane far outperforms 11 other additives. So here we have a pretty good body of evidence to support Asparagopsis. The second part of the competitive analysis compared Blue Ocean Barns' positioning relative to other companies. So there are a handful of companies around the world that are trying to grow and process Asparagopsis at scale. And so I compared all of these companies in terms of their claimed methane reductions, their licensing, their cultivation techniques, and their funds raised. And I found that Blue Ocean Barns is really one of two startups globally that is really well positioned to successfully produce Asparagopsis at scale. And scale is a really crucial part of this because in order for this technology to actually make a meaningful impact, we pretty much need all cows in the US to be eating it, not just a few farms or a few boutique farms. And that's a lot of seaweed when you add it all up. And so Blue Ocean Barns meticulously researched methods of cultivating have this promise of scale where other companies don't. So next, I actually worked with Patrick Cage, a former CSP student, to analyze the actual emissions reduction from Asparagopsis in the form of a life cycle analysis. So when I say 80% reduction in methane, that's actually not the whole picture because there are emissions associated with cultivating, processing, packing, and transporting the seaweed. So this effort took a really rigorous and holistic look at the cost and energy necessary to produce Asparagopsis. And this is critical for a number of reasons. First of all, in just determining how large of an impact this can have. Also for maximizing the efficiency of the facility, this gave us information on which parts of the process are the most energy intensive, which are those that we want to focus on trying to reduce. And then also this is really important for verification of carbon credits for participation in the voluntary carbon market. So in a nutshell, we took an inventory of every input in the system, which fell into three categories of energy, labor, and transportation, and then added up all of those inputs with the outputs to determine this thing that we call the emissions per emissions reduced. And you can think of this as how much CO2 equivalent was used to save 1 ton of CO2 equivalent. And what we found was that the emissions per emissions reduction range from about 1.5 to 13.8%, which actually suggests that Asparagopsis is very likely to deliver net emissions reductions. So that means that it takes about 1.5 to 14 tons of CO2 equivalent to reduce 100 tons of CO2 equivalent. So thus far, we have a pretty compelling argument that Asparagopsis is the best additive for methane reduction, that blue ocean barns is pretty well positioned to produce Asparagopsis, and that even with the cost of producing it, it will still deliver a net decrease in emissions. So now let's get into some regulations. Livestock feed and feed additives are regulated in a way such that we can't just add ingredients to cow feed without going through proper channels. However, this actually poses a pretty big challenge because seaweed has never been added to cattle feed before. And while there are a lot of rules and regulations about what can and cannot be added to livestock feed, nothing dictates what to do with seaweed. So the big question is, how do we utilize the existing regulatory structure creatively to ensure that a novel solution can make it to market? And so feed additives, it turns out, are regulated at both the state and the federal level, which adds another level of complexity. So I did a deep dive into a lot of really bad government websites and long regulations and statutes to figure out where Asparagopsis might fit. And through lots of really murky language and policy jargon, which I will spare you all, we actually did find a path to approval. And just last month, we were actually approved in California. So this means that blue ocean barns can actually start distributing their seaweed to farmers in California. And this includes a local organic dairy, Strauss Farms Creamery, as well as Clover. We're also pursuing approval in Vermont to provide seaweed to the cows at Ben & Jerry's. So soon, some of the most recognizable dairy products will have a significantly lower methane footprint. And finally, I had the opportunity to use all this information to craft policy briefs. So these briefs summarize the issue with enteric methane, the capabilities of Asparagopsis, and recommendations on how best to propel this solution forward. And these briefs hope to not only serve blue ocean barns, but also inform a wider audience of the opportunities to utilize Asparagopsis throughout the country. So audiences thus far have been pretty limited to a small part of the scientific community and in the startup space, but I believe it's really necessary to reach wider audiences, especially those with policy decision makers, to ensure that the full potential of Asparagopsis is reached. And for this reason, I wrote a number of versions of the policy brief, each for a specific audience. And what I find so compelling about Asparagopsis is that it kind of has something for everyone. Conservative farmers and producers might be intrigued by the fact that it's able to increase energy conversion in cattle, and that it's really easy to use on the farm. Folks at the federal level might be interested in its potential to help reach this administration's methane pledge. And consumers are given the opportunity to support climate solutions every time they go to the grocery store. So this solution really bridges the divide between red and blue, and it's kind of a win for everybody. So there are a lot of lenses through which you can look at Asparagopsis, and these briefs aim at capturing each one. So I'm still working on getting these out to the correct audiences and in the right hands, and I'm excited to continue working with people at UCSC to do this work. So learning and moving forward, I learned a lot about cow digestion over the course of this project, more than I thought I ever would. But I also learned a lot about what it means to take a good idea and try to make it stick, because having a good idea is actually not enough. I also learned that we're really at a critical time as a planet, and this is just one of the many, many climate solutions that are going to come. I plan to continue working in the solution space, and I'm really grateful for my experience with Blue Ocean Barns, which has taught me creativity, flexibility, and a lot of patience. And I'm really eager to see how Asparagopsis changes the cattle game and how Blue Ocean Barns will continue to lead the way. Of course, none of this would have been possible without a whole team of support. So I want to thank Vivian Hay and Joe Solwin at Blue Ocean Barns who made this project possible. Big thank you to my advisors, Christy Croker and Anne, who had my back the entire time through a lot of twists and turns. It's been a really strange 2 years to be a graduate student. I also want to thank my cohort as well as the Croker Lab, who provided a really warm and kind community of support. And a special thank you to Dave Kowick, who's been an incredible mentor and has been a real highlight of my grad school experience. And lastly, thank you to everyone who came out today to listen. Thank you all.